Hi guys, this is Mr. Adams from Midwood High School, and this is a video on analyzing redox reactions. Okay, you can be asked to figure out whether a reaction is redox or not. Okay, now you'll also be asked to figure out, okay, the substance that's oxidized and the substance that was reduced. Okay, and you'll also be asked about oxidizing and reducing agents. Now, to figure out the substance that was oxidized, you simply have to determine, right, whose oxidation number, right, increased, all right? And to figure out the substance that was reduced, you will determine whose oxidation number decreased, okay? All right. Now, I'll skip agents for a second. Now, the first thing you got to do, guys, is very, very important. Please do the 3 worksheets that we did assigned before. Please be able to master putting your oxidation numbers in. So we know phosphorus here is by itself. Okay, so its oxidation number will be 0. Okay, all right, let's put a 0 there. Now, H most of the time is what? H most of the time is +1. Okay. O most of the time is -2, right? Okay, so what's N going to be? Now, guys, the reason I'm doing this video is that this one has a lot of coefficients in it, right? But notice that the coefficient has no bearing on the oxidation numbers. So I want to emphasize that. In the other video I'm going to give you, I don't think I use coefficients in the reactions. So I just want to clear up any misconceptions. Okay, so we have one nitrogen, which is +1. Okay. We don't know, one hydrogen. Hydrogen is +1. We don't know nitrogen. Okay. And we have 3 oxygens, right? And 3 times -2 is -6, right? Okay. So this guy right here is a neutral compound, HNO3. Okay. So if +5 goes here, right, that will make everything add up to 0. So nitrogen has a charge of +5, okay, in nitric acid, HNO3. In water, O most of the time is -2, and H most of the time is +1. So water is nice and simple. Moving on to NO, okay, you go with what you know. Most of the time, O is going to be what? -2. And N in this case right here, in nitrogen monoxide, is +2. Okay, so +2, -2 give you 0 for a neutral compound. And for H3PO4, right, phosphoric acid, we know H most of the time is +1. O most of the time is -2. We don't know what phosphorus is. Now notice we have 3 hydrogens here, right? So what's 3 times +1? 3 times +1 is +3, right? Write it in there. Oh, goodness. All right, try it again. +3, right? Okay. We don't know what that 1p is, all right, yet. And we have 4 oxygens, right? And each of them is -2. So 4 times -2 is -8, right? Oh, goodness. I can do it. And -8. So what plus +3, okay, and adds up with -8 to give you 0. Okay, that's going to be +5. Okay, so +5 goes there for phosphorus. Now, we can do some, answer some questions. The substance oxidized, right, as we said before, that guy's oxidation number will increase, right? So we look at phosphorus right here. He's going from 0, right, all the way up to +5. So you would say this guy right here, okay, is important now. You would say P0 with his 0 oxidation state, that guy got oxidized. Okay, so your substance oxidized was P0, all right? The substance oxidized, the substance reduced, okay, there will always be where? There will always be on the reactant side. Also the agents, guys. Okay, so make a note of that. Substance oxidized, substance reduced, always on the reactant side. Okay, so who got reduced? Whose number went down? So we know it's not phosphorus. Phosphorus went up, right? Let's check hydrogen. Hydrogen's one here, one there, one everywhere. So hydrogen didn't change. So hydrogen didn't undergo any type of oxidation or reduction, right? He stayed the same. But let's look at nitrogen. Nitrogen just so happens, right, to go from +5 right here, okay, +5, and he's going to here, +2, right? So if you go from 5 down to 2, you're being reduced. So that substance, it got reduced, okay? So this guy right here, N, okay, in the +5 oxidation state, that guy got reduced. Now, why am I emphasizing the oxidation state? Because they can give you multiple choice questions, right? And ask you who got reduced, who got oxidized. And I've seen on reading exams where they put N+5 and they put the N+2. You with me? With the phosphorus, the both phosphoruses, the O phosphorus with a 0 and phosphorus with a +5, and ask you who got reduced. You must specify the guy on the reactant side. Okay, if his number went down, he got reduced. Okay, don't just choose any nitrogen. Okay, because you lose points for that. Alrighty, so let's go to agents real quick. Now, here's the deal. I said before in the other video, but I'll say it again. A travel agent, right, does not travel with you. He causes you to travel, okay? So, the easiest way to recognize agents, right, if you want to know who's the oxidizing agent, right, okay, you flip this name around. To find the oxidation agent, it's the substance that got reduced. I'll say it again. How do you figure out agents? You flip the name around. So oxidizing agent is a substance that got reduced, and this guy right here, nitrogen +5, is your oxidizing agent. Let's try again. Let's try reducing agent. Okay? So to figure out who's the reducing, okay, RED for short, reducing agent, what do? I flip this name around. The reducing agent is a substance that got oxidized. And who got oxidized? P0. Okay, so P0 is your reducing agent. Okay, so you'll practice some of those with the worksheet I send you today. All right, let's move on. We're almost there. Double replacement reactions are never, never redox, people. Okay, and two examples of double replacement reactions are neutralization, your regular acid and base reactions that we learned before. Okay, and if you notice, if you have two ionic substances on your reactant side and two ionic substances on your product side, that's going to be also double replacement, and they will not be redox. Now, what I'm going to do to you, I'm going to prove to you that this neutralization reaction in A is not redox. You can do B for yourselves, put numbers in, and you'll see they won't change. It should not change. All right. So we know H, right? H is +1, Cl is -1. Na is in group 1, so he's always going to be +1. Okay. O is -2 most of the time. H is +1. Na, once again, is in group 1, is +1. Cl is -1, right? Now, water we did before on the previous slide is +1 for H and -2 for oxygen. Now, guys, anywhere in this reaction from the left side, okay, left side, reactant side, to the product side, right? We notice none of the elements changing number. H is still +1 on both sides, Cl is still -1 on both sides, and O is -2 on both sides. So once again, neutralization reactions is a type of double replacement reaction, okay? They're never, ever redox. Try this reaction right here, okay, on your own. See how it works. You'll probably notice also that the numbers do not change. All right, guys, as always, hard work plus sacrifice equals success. Hope this video has helped. Keep safe, follow precautions, and we'll get through this. All right, take care.